Quick review on exponents and rules with exponents. So first of all, the very most basic thing I can think of, 2 to the third power. Does that equal 8 or 6? If you think it equals 6, then you really have to pay special close attention to this because you don't remember anything about exponents. When you have an exponent, you don't multiply 2 times 3, you multiply this number 3 times. So it's 8. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 3 2's because the exponent's 3. Okay, that's your basic introduction. Now we're going to multiply the same number together. 2 times 2, which everybody knows is 4. But now this 2 is going to have exponents with it. So it might be like 2 squared times 2 to the third. So what is that answer? Well, you could put these into numbers. 2 squared is 4, and 2 to the third is 8, we just said. And 8 times 3 is 32. However, when you get this problem, most likely 32 is not going to be one of your choices. They're going to want you to write that as 2 to what power? So 2 to the what power? What goes in the box here? What is our exponent? That's the question. And 2 to the what is 32? Well, 2 squared is 4, 2 to the third is 8, 2 to the fourth, 16, 2 to the fifth is 32. So it's 2 to the fifth. And now you can probably recognize what the rule is. The rule is when you're multiplying the same thing together, whether it's a number or whether it's a variable, you could have x squared times x to the third. The rule is you add the exponents. So when your base is the same, whether it's a letter or number, you add the exponents. This would be x to the fifth, that's 2 to the fifth. This is just a good way to remember it. If you're not sure if this is 2 to the fifth or 2 to the sixth, you could turn these into real numbers and you'll see that, oh, it's 2 to the fifth. So you can check yourself with 2. Okay, when do you multiply these together? There is a time when they get multiplied together. And it's this occasion right here. If you have 2 squared raised to the third power, whenever you raise something to a third power, you're multiplying it 3 times in a row. So just like 2 to the third was equal to 2 times 2 times 2, 2 squared to the third power is equal to 2 squared times 2 squared times 2 squared. You see that? See what I'm doing there? This thing 3 times. This thing 3 times. So when you get 2 squared 3 times, now you're back to this rule. You're multiplying the same base number, the same 2. So you add the exponents and you get 2 to the sixth. The shortcut, the rule is when you raise an exponent to another exponent, you multiply those exponents. 2 times 3 is 6. So this is when it's 2 to the sixth. This is when it's 2 to the fifth. You got to know the difference between that. Multiplying is a shortcut for adding. 2 squared to the third is just adding 2 3 times. So it really is all this rule right here. This is just a shortcut if you want to multiply it instead of expanding it out to 2 to the sixth. All right, another rule, subtracting exponents. When would we subtract exponents? Well, we add them when we multiply, so we subtract them when we divide. That's right. So if you have 2 to the fifth divided by 2 squared. Well, 2 to the fifth is 32, 2 squared is 4, 32 divided by 4 is 8, and 8 is the same thing as 2 to the third. We could have gotten 2 to the third right away by just doing 5 minus 2 is 2 to the third. 2 to the third. So if it's 2 to the fifth times 2 to the 2 squared, that's 2 to the seventh. When you multiply, you add. When you divide, you subtract. Okay? What if the denominator exponent is bigger than the numerator? What if it's 2 squared over 2 to the fifth? Well, when you subtract, it's 2 minus 5 now, so that's 2 to the negative 3. What does that mean? What is a negative exponent? And here's how I usually teach negative exponents. I'll say 4 squared, people. What's 4 squared? And everybody yells out 16. Good, you know that. Then I'll say, what's 4 to the negative 2? What's 4 to the negative 2? And everybody wants to say negative 16, and that is incorrect. It's not negative 16. It's actually 1 over 16. A negative exponent means flip it. Flip that number. When I say flip it, I mean move it to the other part of the fraction. Right now the 4 to the negative 2 is in the numerator, so you would put it into the denominator, and that's how you get 1 over 16. Once you move a negative exponent, if it's in the numerator and you move it down to the denominator, now it becomes positive. That's how you get rid of the negative. So 2 to the negative 3 is the same thing as 1 over 2 to the third power, which is the same thing as 1 over 8. So if you get, this is where this gets tricky. If you get this problem on a test, your multiple choices might be any one of these three things. Any one of those three is considered correct. Now, you won't get both of these as choices. This won't be choice A and that's choice B, and you got to pick which one's better. It's not like that. It's just you'll get one of these three here, and you got to recognize that all three of these are correct. Okay. Same with down here. If they say, what is 4 to the negative 2? Your answer might be 1 over 4 squared, or it might be 1 over 16. They won't give you both, but they could give you either or. So you got to recognize that those are both correct. All right, I kind of raced through that. That's pretty much all the rules. Well, there's one more. What if the exponents are the same? What if you have 2 to the third over 2 to the third? Well, that's the same thing as basically 7 over 7. When you have the numerator and the denominator are the same, they reduce to 1. Well, the numerator and the denominator are the same, so it reduces to 1. So that's 1. But what if you use the subtraction rule? What if you said, well, when you divide, you subtract. So you do 3 minus 3, and you get 2 to the 0. Well, you'd be right. You would get 2 to the 0. Therefore, 2 to the 0 equals 1. Anything to the 0 power equals 1. 5 million to the 0 power equals 1. So anything to the 0 power equals 1. Anything to the first power is just itself. So 7 to the first power is 7. 7 to the 0 power is 1. All right, let me do a couple more examples here with you, and then I'll be done with you. When you got a whole bunch of stuff inside of a parenthesis raised to a power, you got to raise everything in there to the 5th power. So we've got three things inside the parenthesis here. We've got a negative 2, an x cubed, and a y. So we got to do negative 2 to the 5th power, x to the third to the 5th power, and y to the 5th power. So negative 2 to the 5th power is negative 32. Why is that negative? Because a negative times a negative is a positive, and then you multiply that third negative, and it flips you back to negative. Multiply by a fourth negative, flips you back to positive, and then the 5th negative flips you back to negative. So basically, if you have an odd number of negatives, your answer is going to be negative, because that odd negative flips you back to negative. So we get negative 32. Remember, an exponent raised to another exponent means multiply, because this is 5 of these, 5x to the third. So we have x to the 15th. And then y to the 5th is just y to the 5th. So that's the answer to that one. All right, here, when you have negative and a positive, you could subtract. Just be careful, because negative 5 minus 2 is actually negative 7. So your answer is 6 to the negative 7, which could also be 1 over 6 to the 7th. And they could expand that out to some huge number, but that won't happen. When the number gets that big, it's going to be one of these two choices. All right, the way I like to teach this is get rid of the negatives first by moving it to the other part of the fraction. So you could move the 6 to the 5th down. The 6 squared stays where it's at because it's already a positive exponent. The 6 to the 5th would move to the denominator to make it positive. Now you don't have any negative exponents. You don't have anything left up top. When that happens, it's a 1. And then you can add your exponents on the bottom and get 6 to the 7th. So it's either 1 over 6 to the 7th or 6 to the negative 7. Those mean the same thing. So you can do it that way, or you can just subtract. Negative 5 minus 2 is negative 7. So it's 6 to the negative 7 or that. All right, last two examples here. Your negative 7 is in parentheses. That doesn't mean anything. You could get rid of those parentheses. There's nothing inside the parentheses. You're just raising negative 7 to the 6th power. Now, you don't have to expand that out. When you get to where it's going to be some huge number, They don't expand it. They just want you to do the exponent rules. And the exponent rules here are, if your base number is the same, which it is, they're both -7, then you can subtract the exponents. So that would be 6 minus 1. If there is no exponent, it's a 1, not a 0. So this would be -7 to the 5th. Okay, then here you want to simplify the top first. You can add your exponents, so that's 4 to the 10th. Nothing to do in the denominator, so that stays 4 to the 12th. 10 minus 12 is -2. So this is either 4 to the -2 or 1 over 4 squared. Now, since that's a small number, they might even show that as 1 over 16. So that could be 3 different answers there. All right, when it's 7 to the 5th, they're not going to expand that out, to 1 over 16. It's not going to be whatever number that is, some huge number. But when it's small, they might do that. So you got to recognize that 4 to the -2 is the same thing as 1 over 4 squared, is the same thing as 1 over 16. There's your crash course in exponents. Might have to watch that again if you're confused on any of the problems.